Today we're going to look at derivatives of general exponential and logarithmic functions. So notice in the box you'll see some derivatives, and it says important derivatives of exponential and logarithmic functions because there are a few others. These are the ones that occur, or you'll see, most frequently. And I would say most frequently is really the first one and this one. So the others do pop up occasionally. This one comes up pretty often, or not often, but a little more frequently. And then occasionally you'll see this log derivative. So we'll focus on just a couple of kinds of these. Okay, so let's do this first example. So f of x is 4 to the 3x. Well, f prime of x equals. So what we're really looking at, I'm going to erase these marks, is this b to the x format. So we have 4, which is our base, raised to the 3x. So there is a chain rule application in here, but what we want to do is take the derivative of the outer function first. So to take the derivative of 4 to the x, we're going to take natural log of 4 times 4 to the 3x. So that's our interior function that we're leaving alone. Then we multiply by the derivative of 3x, which is just 3. So this, I'm going to rewrite it, but you really don't even have to because it's going to look pretty much the same. So this is 3 times 4 to the 3x times natural log of 4. Okay, so for the second example, it's actually a little more simple. It's just 5 to the x. So f prime of x, applying that formula, is just natural log of 5 times 5 to the x. And that would be it. Okay, so new example, y equals x times natural log of x. So this is a product rule. The product being x times natural log of x. And we just go through this. So this would be the derivative. So if we name these like u and v, u prime is 1 times natural log of x plus x times the derivative of natural log of x, which is just going to be 1 over x. And then we simplify. So we get the natural log of x plus 1. Okay, so here we have a similar problem. Y equals natural log of x squared, so this is a chain rule. So y prime equals the derivative of the outside, so bring down the 2, times natural log of x, now it's to the 1, multiplied by the derivative of natural log of x, which is just 1 over x. So y prime is 2 over x times the natural log of x. Okay, do another natural log. So natural logs are the ones that occur the most frequently, so that's why I'm doing a lot of these. So the derivative of that is going to be the derivative of the outside, leaving the interior function alone. So the outside function is natural log, the interior function is x cubed plus 1. So you're going to have the derivative of the outside, leaving the interior function alone, times the derivative of the interior function, which is 3x squared. Okay, so another natural log. Now we have a sine function inside of it. So I'm going to rewrite this one first to be the natural log of sine x raised to the 1/2. Okay, so if you remember the logarithmic rules, we're not going to, I'm not taking a derivative right now, but if you have the log of something, you can bring down the exponent. So this would be the same as 1/2 natural log of sine x. So that is not a derivative, that is just the properties of logarithms. Okay, now let's do the derivative. Let me see if I can choose a color that's not. Okay, so y prime, and I'm going to start with this over here. Y prime is the derivative of the outer function, and I'm just going to hold back this 1/2 because we can multiply it at the end. So this would be times 1 over sine x, so this is a chain rule, times the derivative of sine x, which is cosine x. So this one, cosine over sine, would be cotangent. So this is really 1/2 cotangent. And I think we have one more yet. So just have this here to as a reminder. So this one is the only one I have that is going to be in this format. And the reason is this just doesn't happen that often. I think there's one or two on the assignment, and honestly, just doesn't happen frequently enough to spend a lot of time on it. So the derivative of the natural log of 10x, we just apply this right side. So it's going to be y prime, if we're calling it y. This would be 1 over the natural log of the base of what we have, which is 10, times x. And that's it.